My name's Tom Hilditch, and I'm working with Dr. David Topping and Professor Jonathan Reed on improving the understanding of the gas particle partitioning behaviour of organic aerosol in different conditions. So firstly, what is organic aerosol and why is it important that we study it? So atmospheric organic aerosol is a highly complex mixture of thousands of unique organic species, all of which have their own individual properties. These properties determine the aerosol's mass concentration, which affects the climate, weather systems, alongside the well-being of humans and ecosystems. So due to the complexity of organic aerosol, the properties of many species must be estimated for inclusion in models, one of which is the vapor pressure. So many lower velocity classes of organics are highly atmospherically relevant, but are poorly represented in vapor pressure estimation tools, which leads to large errors in their estimated vapor pressure, and therefore large errors in their modelled mass concentration. So as well as thermodynamic properties, kinetic factors such as viscosity, which control the time dependence of mass transfer, are also currently lacking in understanding. So this leads me to my research plan. Firstly, I'll address the lack of representation of low volatility compounds in the vapor pressure estimation tools by experimentally measuring the vapor pressures of a selection of organic species, an example of which being nitroaromatics. These values will then be used to refine UMAN-CIS-PROP, which is a vapor pressure estimation tool developed in the University of Manchester. I'll then move on to the time dependence of mass transfer in organic aerosol, with a series of viscosity and chemical reactions in droplet experiments. So the results from this and the refined UMAN-CIS-PROP tool will then be fed into a zero-dimensional aerosol box model called PyBox. For the experiments I outlined in my research plan, I'll be using the Electrodynamic Balance and the Aerosol optical tweezers. Both of them work on the principle of trapping a droplet on the order of picolitres in volume and measuring its radius with time, which, depending on the experiment, can be used to calculate the vapor pressure, hygroscopicity, viscosity, and other properties. So the electrodynamic balance is more appropriate in experiments with more rapid mass transfer over a larger size range and is capable of very tight controls of the chamber conditions, whereas the aerosol optical tweezers is more appropriate for measuring very small changes in radius, i.e. for slow mass transfer, and can give information about the refractive index and the chemical composition of the droplet real time through the Raman spectrum. Lastly, I want to introduce the computational end product, which is PyBox. PyBox is the zero-dimensional box model which calculates the partitioning of organic aerosol with time. As can be seen from the schematic, firstly, a mixture of natural and anthropogenic organic gases are entered into the model. Then the master chemical mechanism is applied to atmospherically age the compounds. Then UMAN-CIS-PROP estimates the vapor pressure of every compound. And lastly, the box model enables the gas particle partitioning of the resulting gases based on their properties.